Hi, hello, students. We're going to move on to problem D now. We're going to go over kind of two more problems. One more kind of using the same shape, just kind of in a different way. Um, we talked about how we could cut this shape into like pieces inside. Well, in this one, we're going to think of this as a large rectangle with a piece removed. So we could think about this as this big rectangle right here, this 9 by 7 rectangle. But this piece right here is just simply taken out or removed. So let's kind of go through the steps. So what are the dimensions of a large rectangle and a small rectangle? So they want to know what are the dimensions of a large rectangle, what are the dimensions of a small rectangle. The large rectangle, let's go and put large, of course, is the 9 by 7. So 9 meters times 7 meters. And the small rectangle is, of course, the 4 up and down. I remember we learned this from the last one. If this is 7, we got to take away the 2 and the 2. So we said 4. And this right here, of course, would be 3 meters then. So this is a 4 by 3 rectangle. So let's go ahead and put 4 meters by 3 meters. And of course, the multiplication means it's kind of the by portion. So the area of the two rectangles. Now all I got to do is just simply do the multiplication, find the area of the large rectangle, find the area of the small rectangle. So large is equal to, well, 9 times 7 is 63. And of course, we're talking about meters squared. The small is equal to, well, 4 times 3 is 12. And of course, we're talking about meters squared. All right, so that's the area of the big rectangle is 63. The area of the small rectangle is 12. Let's go and look at the next part. It says, what operation is needed to find the area of the original figure? Well, remember, the original figure is this big rectangle, but this part is removed or taken away. So, of course, the operation would be just simply subtraction. We're not going to have this portion in there, so we subtract it out from the larger figure. All right, it says, what is the difference between the area of the big rectangle and the area of the small rectangle? So now we go ahead and do our 63. Oops, let me get this out of the way. Minus the 12, and that gives us the 51. And of course, we're talking about meters squared still. So what we're doing is we took the big rectangle, subtract the small rectangle. Of course, it gives us 51 meters squared. This is, what do you notice about the answer to A, B? We didn't do C and D. And of course, hopefully you notice that they're all the same. All answers are because they're all 51 meters squared. And the question I want you to answer is, why do you think this is true? Why do you think that all the answers are exactly the same? If we did part C, it would also be 51, but all of these are the same. So write a little statement in here. If you need to, pause the video and write a little statement about why you think this is true. Why are all of these answers exactly the same? I said pause the video if you need to. When we come back, we're going to move on to our last piece. All right, the last piece is we're going to talk about this shape called a trapezoid. Now, there is a formula for the trapezoid, but we're going to kind of talk about how we can deconstruct this or excuse me, decomposing this trapezoid into shapes that we know. So this is trapezoid below is a scale drawing of a garden plot. So this is a garden plot. Just find the area of both triangle ABC and ACD. Well, ABC, there is no triangle. A triangle would have to be cut right here. That would give us a triangle. And the triangle ACD, once again, would also need a line here. So what they're telling us to do is to cut this triangle across here from A to C. Now I'm going to try to draw this as straight as possible, but of course, it's not going to be perfect. So as you can see, if we cut that right there, what that gives us is two triangles. It gives us a triangle here, and it gives us a triangle here. Well, this triangle right here on top, it has a base of 4. The question is, what is the height? Well, the height is right here. Remember, the height of this trapezoid is the height for both triangles because it goes from the top of the trapezoid to the bottom of the trapezoid. So this 5 right here is the height of this triangle, and it's also the height of this bottom triangle. So we should be able to find the area of both of these triangles. So it says find the area of the trapezoid. Well, to find the area of the trapezoid, find the area of triangle 1 and triangle 2. So let's go ahead and go through our steps. So let's go ahead and go over or go through. Let's go and start with triangle ABC. Triangle ABC, so ABC has a base of 8, a height of 5, and then of course we're going to multiply it by, so we're going to multiply 8 meters times 5 meters times 1/2. If we if we do that, oops, that gives us an area, of 20 meters squared. Now, if I find the area of the other triangle is ACD. Well, ACD has a base of 4, right? Because this is the height, so that this connects to the base, a base of 4 and a height of 5. So 4 meters times 5 meters, and of course times 1/2, or of course you could put divide by 2. All right, so let's go ahead and find that area now. So the area of ACD is equal to, well, 4 times 5 is 20, half of 20 is 10, and of course we're talking about meters squared. So what is the area of the entire trapezoid? Well, this triangle plus this triangle give us the area of the entire trapezoid. So now we go ahead and add those two together. I'm simply going to go write them in here. So we have 20 plus 10, and of course that equals 30. And of course we're talking about, because we're talking about an area, we're talking about meters squared. So as you can see, even there is a formula for the area of a trapezoid, but this is a way of we can start seeing what that formula could be or may be. But we can simply cut that into two triangles, find the area of one, find the area of the other, and just simply combine them together. So very, very similar to what we did on the other one. All right, so that's what we're doing today. That's what we're working with today. We're taking shapes and finding missing measurements, or we're trying to find the area of a kind of odd composite figures. All right, go ahead and stop the video and go ahead and move on for the day.